Alright, this is going to be lesson 12.5, the law of cosines. We'll get to those notes here in a second. The homework is going to be out of the textbook again, and I will upload a PDF of the questions in case you don't want to log on to the book. But it is pages 826 to 828, and I'm going to modify this a little bit from last year. You will not do numbers 37, 40, and 42. So only do the first 6 questions, 10, 12, 18, 20, and 28, parts A and B only. So from yesterday's video, we found the area of a triangle using 1/2 BC times the sine of A. So we have the two sides there, 13 and 10, and the angle of A would be 74 degrees. So if you type all that into your calculator, you'll get 62.5 square feet. Also, we talked about the law of sines in the previous video. You could take the angle at B, which is sine of 125, over its opposite side, 8, and then make another ratio. If you want the angle A, you can have sine of A over its opposite side, 5, and use cross products. So when you type this in, you would have 5 times the sine of 125 over 8, and you need the inverse notation to get the angle. So I'll show you that one more time. If I make sure it's in degree mode, go alpha y equals, type in 5 times the sine of 125 in the numerator. You can close the parenthesis over an 8. If you do that, you're going to get a decimal. You should know that that's not possible for your angle. So then you need the inverse sine of that. So second sine, go get the decimal, press enter, and it's about 31 degrees. Likewise, I can set up another ratio to find the side length of C. So sine of 125 degrees over 8, and then the sine of 24 degrees, which I'll tell you how we got that in a second, over the opposite side of C. So again, you could do cross products there and solve for C, which is 4. Now, how did you find the other angle of 24? Well, you already had 125 and 31. If you add those together, you get 156. And if you subtract that from 180, you'll get that angle C was 24 degrees. So remember, when you solve a triangle, you need to find all 3 measurements of the sides and the angles. All right, so here's the new material, law of cosines. So you're going to be using the law of cosines when you have the measures of 2 sides and the included angle, so the side angle side case, or if you have the measures of the 3 sides that are known. So nothing about the angles is given, but you know 3 side lengths. So I'll show you an example of each of these. And there's 3 different equations there for the law of cosines depending on what angle that you are given. So this first example here on the right, solve the triangle given 2 sides and the included angle. So solve this triangle. Find all 3 angles, find all 3 sides. What was given to us was 2 sides, 7 and 5, and the included angle at 36. So this is the side angle side case. The angle that was given is angle B. So if I look to my left and look for cosine of angle capital B, that middle one, that is the equation I'm going to use to solve this one. If I had the angle A, I would use the top equation. If I had angle C given to us, we would use the third one. But since angle B was given, we're going to use that middle one. B squared equals A squared plus C squared minus 2AC times cosine of angle B. So I'm just going to substitute everything that we know into this. So angle B was 36. That goes in for capital B. The 7 was opposite of capital A, angle A, so that is what lowercase a is. The 5 is lowercase c because it was opposite of capital angle C. So you can see I substituted that in. B squared equals 7 squared plus 5 squared minus 2 times 7 times 5 times the cosine of 36 degrees. Now, the whole left side or the right side of that equation, you could type directly in your calculator and you'll get 17.4 and then you have b squared equals that number. So in order to undo the square, you have to square root both sides. So the measurement of the third side, b, is 4.2. And then we need 2 other missing angles. So we can start using the law of sines from yesterday. So we have angle B was 36. Its opposite side we just found was 4.2. So write that as a fraction. If I want angle A, you have sine of A over its opposite side, 7. And again, you can cross multiply. So you'd have 7 times the sine of 36 divided by 42 or 4.2. And you'll probably get a decimal. Remember, you need the inverse sine of that, and you'll get 78 degrees to the nearest whole number. So once I have 2 angles, you can add them up and subtract it from 180 to find the third angle, which is 66 degrees. Now this next example is going to be one where they give us the 3 sides of the triangle. Excuse me. So when you're only given the 3 sides, you can start by using the law of cosines. And the first step is to find the measure of the largest angle to ensure that the other 2 are acute. So always look for that obtuse angle to find first. So we're going to find angle A. So up here in our 3 equations for the law of cosines, I want the one that has cosine capital A at the end. So it's going to start with a squared equals b squared plus c squared minus 2bc times the cosine of angle A. And like before, I'm going to substitute all the variables that I know. So I know that the angle that was opposite of A was a 16, so that is lowercase a. The side that was given to us that was opposite of angle B was the 9, so that fills in for the lowercase b. The side that's opposite the capital C was 10, so that fills in for lowercase c. So notice the capital A is the part that is missing here. So we have 16 squared turns into 256, 9 squared is 81, 10 squared is 100. If you add those together, you get 181. The next part, negative 2 times 9 times 10 is negative 180 times the cosine of A. Now I highlighted the 180 cosine of A part because some students will just take 181, subtract 180, and do that part first. But you have to multiply before you can subtract. So we need to not think that's just 1 cosine of A, but get rid of the 181 and move it to the left-hand side first. So 256 minus 181 is 75. And then you're left with negative 180 times the cosine of A on the right side. You can divide both sides by negative 180. You're going to get a negative decimal on the left. And this time you need the inverse cosine. So you would go second cosine and type in that decimal, that negative decimal, to get that the A angle is 115 degrees. Now you should make sense of your answer. It's an obtuse angle, so it should be higher than 90 degrees. If you get something that's less than, you made a mistake somewhere. So now that we have angle A, we can use the law of sines from before. So set up a ratio. So sine of 115 degrees over its opposite side, 16. And then if I want the angle at B, I can use sine of angle B over its opposite side, 9. Use cross products again, the inverse sine, and you get the angle at B is 31 degrees. And now you have 2 out of the 3 angles, so you add up 115 and 31 and subtract it from 180, and you get 34 degrees for the angle at C. So on the right here, there's 2 extra problems for you to try on your own. The answers are given there, so you can work through that on your own. You can pause the video if you need to, work that out on a piece of paper. And then to wrap up this lesson, there's a few word problems here, just 2 of them. So how do you know which one to start with, law of sines or law of cosines? So that's the big picture here. So if you had 2 angles and any sides, you can use the law of sines. if you had two sides and an angle that's opposite of one of those sides, you can use the law of sines and write the ratios. If you have two sides plus their included angle, you want to use the law of cosines. And if you're only given the measures of the three sides, you can only start this by using the law of cosines. So here we're going to look at a scuba diver. He looks up 20 degrees and sees a turtle that's 9 feet away. And she looks down 40 degrees and sees a blue parrotfish that's 12 feet away. How far apart are the turtle and the blue parrotfish? So together, that whole angle, 20 plus 40, would give you an angle of 60 degrees. So I have two sides and the included angle. So you're going to use the law of cosines on this one. And I know the angle at A, so I'm going to use that law of cosines that has cosine of capital A at the end. So we're going to fill in everything we know. So 12 is what lowercase b is. It's opposite of angle B. And we also know 9 is opposite of angle C, so that's lowercase c. So you filled them in there. And then the cosine of angle A was 60 degrees. So if you type the whole right side in, you get about 117, square root both sides, and it's about 10.8 feet between the turtle and the parrotfish. You'll have two problems in your homework where it will say, determine whether each triangle should be solved with starting with the law of sines or cosines, then solve the triangle. So you have to look about what is given here. So on 5, you have two sides and an angle that's opposite of one of those sides. So if you go back up to the chart, I had two sides and an angle opposite of one of them, so that is the law of sines. And I won't go through the work, but the answers are there for you to work out on your own. Number 6, we were given two side lengths and the included angle. So if you go up to the top, two side lengths and their included angle is starting with the law of cosines. And you would want to use the one that had cosine capital B at the end, since B is the one that you know. And there are the three other parts of that triangle, the two angles and the missing side. And the last problem here, in a football game, the quarterback is 20 yards from receiver A. He turns 40 degrees and sees receiver B, who's 16 yards away. How far apart are the two receivers? So this picture wasn't given at first, so I sketched one out. There's good old Tom Brady there, trying to decide whether he's going to throw it to player A or B. B's a little closer to him, but their angle is 40 degrees to see one or the other. So I want to know how far apart are the receivers. So we know the two sides and the included angle. So we're going to use cosines here. And cosine of C is the one I'm going to use. So I know that lowercase b is 20 yards because it's opposite of angle B. And I know lowercase a is 16 yards because it's opposite of angle A. So I filled those in. I also know the cosine of C, so I know the angle at C is 40 degrees. So I substitute that in. Figure out the whole right side. Type that carefully into your calculator. You get 166. And if you square root, you get about 12.9 yards.